Welcome everyone to a talk which is in theory about DevOps, but I would say we'll tackle some a lot broader areas of discussion. And in general, I would say it's about software delivery and about performance in software delivery. Over the years, I've talked to a lot of customers and technology leaders, and I would say without exception, they all consider, they would have statements in the lines of we do DevOps, we love DevOps, we understand the value that DevOps can bring to our organization. And yet, when you look at our industry as a whole, I would say we're doing a rather poor or average job at delivering software with high performance. Sorry. And if you think about it, maybe some of you might know these kind of graphs. It's called the Gartner Magic Quadrant, and what Gartner does is it does a lot of research where it evaluates companies in various industries, and it does so along two dimensions. One dimension is the completeness of vision, so its strategy, what kind of features is it offering, and so on and so forth. So what is my focus on? The other dimension is the ability to execute, right? And if you look at this, well, specifically this one is about cloud infrastructure providers. But if you think about it really on a general term, this kind of graph tells us one important thing. Having a cool idea is very important, but it's at most half of the story. The other half is being able to bring that idea into production, so the ability to execute. And I define ability to execute along two dimensions. One is speed, and the other is reliability. So what do we know about our industry in terms of how we deliver software, how our speed and our reliability is? Well, actually, we know quite a lot. There have been these State of DevOps reports for quite a number of years now. And I have to say, when I first read my first report, I was quite literally shocked because, let me give you a little bit of background. What they do is they go and survey companies, and they have defined 4 metrics. 2 of them go in the area of speed, so lead time and deployment frequency. How much time does it take for me to turn an idea into a productive software? And how often do I deliver software into production? And the other 2 metrics are concerned with reliability. So let's say change fail rate. What percentage of my deployments lead to some sort of error? And mean time to recovery. How long do I need in order to recover from a problem if that has occurred? And the astonishing and quite counterintuitive result is that they did the survey on companies and they found out there are these kind of clusters and there are these high performers, and surprisingly, they are both delivering software both faster and with a higher quality. So if I was to drive a car with 5 kilometers per hour and you were to drive with 200 kilometers per hour, I would expect that your likelihood to run the car into a wall is a lot higher than mine. So in a way, counterintuitively, this doesn't apply to software delivery, or at least doesn't appear to. Does anyone have an idea why do you think high performers are able to do both of these better? Sorry, I heard something. High velocity, how? All the tools, okay, yeah. So experience, okay. Automation, that's a big one. Smaller iterations, exactly. Okay, so we're on to something there, right? And indeed, what the guys that are doing the state of DevOps reports, they also published a book that's called Accelerate, and I encourage you to read it. And they really found that there are some common traits among the high performers, and we're going to look into them today. But the point is, yes, automation is at the core of what these companies do. But automation is not, it's only part of the story. If it would be just about writing infrastructure as code and delivery pipelines, we would just learn scripting languages. We wouldn't have a problem. Everyone would be high performers. We wouldn't be having this talk, right? And the problem is, unfortunately, I'll say it up front, there is no one solution for everyone. There is no silver bullet. Everyone just does this and they're high performers. And what we're going to talk today is what we can do about it. But before we go into the details, what I want to do now is, if you could take out your phones, hopefully you can scan that QR code. And at the end, we will do like a short review of where everyone stands. There is only one question on that survey, which is basically asking you, what is your deployment frequency? How often are you bringing stuff to production? There's an, yeah, right. Just take the best one if you're in the best category. Does it work? Does the survey page work? All right. Okay, so you can do that, and we'll have a look at the results at the end. So like I said, there is unfortunately no single silver bullet, no single solution. The single best thing that I have managed to come up with is more of a mindset shift. We have to stop thinking of software delivery as a one-time process and more as a repeated loop where obviously we're going from development to delivery to monitoring the application and so on. But the one most important step in there is to continuously reflect on our delivery process and have a look at our bottlenecks. What is stopping us from becoming high performers? And in essence, what we've learned is that what makes this a so complicated question is that DevOps is a very interdisciplinary topic. So a lot of things can manifest themselves as roadblocks for your delivery performance. It can start with how your teams are set up, to going on to how your architecture is designed, how your delivery processes are designed, how you do testing, and so on and so forth. So all in all, unfortunately, quite a difficult problem without one single solution. So what we'll do today is that we'll try to share some of our lessons learned, and I see you're open for discussion, so I do hope that this will be more like a discussion and a debate. What I've brought is just some of our lessons learned from the last 1 or 2 years in a product that we're building. It's called an MSG marketplace. It's a marketplace for building, for purchasing and consuming API products. So, first things first. One of the things that you probably know or heard of is this idea of continuously delivering value, right? It's like a mantra of the agile philosophy, where it says, okay, let's always try to ship value in small increments, always have a stable functioning product, and don't try to take half a year for development. So one one technical practice that these high performers all seem to have in common is that they do something called trunk-based development. Is anyone doing trunk-based development? More or less, all right? Okay, so we also said, okay, basically we can take this a bit more lightly and call trunk-based development just having short-lived feature branches. You have one stable line of development and you aim to have feature branches that have a lifespan that is as short as possible. What does this lead to? Well, it leads to the fact that you can deliver small increments of value, what we've heard before, continuously, and you also always have this stable trunk. What we've seen, however, in practice is that this kind of approach very easily degenerates, I would say, into more long-lived feature branches. So this is more the reality. And I think you all know what's going on in here. You have a really long time to feedback. You're working, I don't know, days is ideal, weeks, months on features. And then it takes a lot of time until you get feedback from production or from your customer. And even worse, you then have multiple feature branches in parallel, and merging those together quickly becomes living hell, right? So coming back to this idea of what have we done to improve this, I would give two takeaways from our side here. One is the pure agile side of things. Learn to slice your user stories small. So work in small batches, right? Even when you think this kind of feature cannot be broken down into smaller capabilities, it probably can. This is something that we've learned over time. This will help you in the later stages in working in smaller batches. And then on the more technical side, really continuously have a look at how you're living this whole integration flow. What kind of roadblocks are you introducing into this merging process? So are your code reviews really as smooth as they could be? Perhaps you're creating a pull request and then you have to wait for 1 or 2 days for the review to be done, and then that creates some wasted time in there. Or you have perhaps a weak test automation suite, and this causes the development team to have the lacking confidence to actually merge directly into master. So that causes them to have this kind of, I want my feature branches to just live longer because I'm not yet sure that it's stable enough. And we'll come back to automated testing afterwards. And then last but not least, think about the fact that having short-lived branches might introduce another problem. It leads you to have multiple builds, perhaps multiple per day. So if your builds tend to last longer, that might become yet another bottleneck where the development team will have to sit around and wait for the builds to complete. So you already see the ramifications and the potential roadblocks that can occur. And I will leave the demo for the end. We'll have a look at an actual project setup in Azure DevOps and some kind of processes that we've come to define as best practice, and see how we live this process there. Now, we already said it. You might have a weak automated testing suite, right? I mean, I see you're all you're engaged with me, so I want to ask you some other things. Who of you would say you have a test suite which gives you the confidence to automatically deploy your code to production without any manual checks? On some, that's already good. I don't know. I'm doing a survey. We're also not there. That's why it always is a question of finding the right balance between automating as much as is possible and then giving yourself time for manual testing, but not relying strictly on manual testing. So what we found, actually what the guys doing the State of DevOps report also found, is that in terms of architecture, there is one principle that contributes most to delivery performance. And that is designing loosely coupled architectures. It doesn't have to be microservices. It's just the idea of building your software in components. And this has a huge contribution to testability. Because what we did initially, if let's say we omitted defining too strong guidelines, and then what you end up with in your application is like this big ball of mud where everything communicates with everything. And the big issue then is being able to test components in isolation. So that's why loosely coupled architectures appears to be one of the key aspects to keep in mind. And if you do keep one thing in, take one thing out of this talk, that should be it. But here, going further, one practice that we've found to be really efficient is using domain-driven design. Anyone doing that? Right, so it's not unknown. The idea is to always start from your business domain and construct your architecture based on your business domain and not the other way around. And what this does is it kind of creates this onion-shaped architecture where the inner layer of the architecture is your business domain with your whole business rules, and your infrastructure is like located as an exterior layer of the onion. And this has a really, really nice side effect because the domain is unaware of the infrastructure, and then when you start writing tests, you'll notice, it's a lot easier for me to write tests because I don't have to mock the infrastructure, I just focus on the domain. I want to make this a bit more concrete. I don't think it's readable, doesn't matter. I will just explain it a little bit. What you have here is, let's say, an automated test before and after our rewrite of the architecture. And the key thing to consider here is the test does the same thing, but in terms of mocking, you will see that the first test, most of the first test is working on preparing mocks, and mocks of what I would consider to be infrastructure. So if it's an API service, you would have to mock the context of the API, some authorization headers, what are the URLs and parameters and so on. Things that you shouldn't care about when you're actually trying to test some sort of business logic. So what happens is when you restructure your architecture and you manage to focus your business logic at the core of your application, you can also focus your automated test suite on that core of the application. And you end up with with a test suite which is a lot simpler to write and to maintain. If you have questions, feel free to interrupt, right? It's supposed to be a workshop, at least that's what's written in the agenda. Next point is optimizing your builds and understanding that all build processes are not created equal. So not every time that someone pushes some sort of code into the source code repository, the same thing should happen implicitly. And what I mean by that is I want to explain our transition in this area. We initially started out with a Git repository structure and a branching strategy that had one branch per cloud environment, right? So you would have dev stage and master corresponding to the dev stage and prod environment. And this in theory has a nice advantage on the side of transparency, because you can very easily see, these features are on dev, these are on stage, these are on prod. But as soon as we started going faster and faster, what we realized with our initial setup was that what we were doing was, for every one of these branches, we would kick off the same build and delivery process. So you would take source code, compile it depending on your language or whatever your environment you're working in, create some sort of binary artifact, and deploy it to the corresponding cloud environment. And this, first things first, this eats up a lot of time if you add it up. And this is not according to this principle of reliable delivery. Build it once, deploy it everywhere. This is how you typically end up with people saying, well, it worked on my machine. I don't know why it works. It doesn't work in production. That's where this whole idea comes from. And what we had to, when we reworked this, we came to a process that looks more like this. We simplified a lot. We just kept that main master or trunk branch, call it whatever you want. And we have exactly one build process that creates the artifact. And we thought about it, okay, what is environment specific? What is specific to dev stage or prod? And exactly those things became part of this environment specific configuration, which we can attach as part of the deployment process. And this then, obviously, like I said, I'll repeat myself, it has two advantages. One is build times are a lot faster, and then reliable deployments. And then, again, we still have this kind of pull request-based flow, where we've seen, okay, we're running some sort of builds also here, but it in no way has to be the same thing running here than it is here. And this is up to you to decide. What do you want to validate before accepting some changes into your master branch? It might be just checking some code quality. It might be already running some automated tests. But the idea is, just keep in mind, all builds don't have to do the same thing everywhere. Right. You might have seen we're kind of moving along in this development and delivery life cycle, and we're now coming to the deployment stage, where we've noticed kind of an interesting thing, right? We all love buzzwords. I also, when I hear about a new technology, a new architecture and so on, I can't wait to use it in my next project. And this is somewhat what we also did here in this project. We started with an architectural style which you may call microservices. That's the left-hand side. You have several components in the Azure runtime that talk to each other. And every one of those components came out of a single source code repository, could be developed independently, and had to be shipped to production independently. And in this case, we have a DevOps team of about 6 people. So when we started going to production more often, we realized, okay, this is pretty complex, because every time I have a new feature, I have to deploy the individual components, have to make sure that everything is nothing has been forgotten. And then you ask yourself, why am I doing it? Do I really need this sort of flexibility? This is where you have to always leave aside hypes, and that's our lesson learned. if we were to scale up this development, and then we would indeed have larger teams and teams working individually on the different components, and the teams would want to be able to deploy independently, then it might make sense. But we said, well, we don't need that kind of flexibility, because right now at least our application can, we view it as a whole, and we can release it as a whole. So as the big bad monolith, right? We have a monolithic deployment. We haven't changed our architecture at runtime, but we just decided to couple the life cycle of the components together. And this means we can deploy them together at the same time. We just automated everything. And then we did another nice trick, because the really tough part about microservices and distributed systems in general is they have interfaces between each other. So component A sends a message to component B, and then someone changes the structure of the message in component A and forgets to do the same in component B. So it's breaking that interface. And we said, well, we don't, like I said, we don't need that flexibility of someone working strictly in domain A and not yet in domain B. But what we want is, as soon as someone breaks the interface, I want a compile time error. I don't want it even to be possible for me to deploy a software which is inconsistent. So what we did is we took all the components, moved them into a single repository, this monorepo thing, and every project, every component became basically a folder in there. And what we did is we took the interface definition, so basically the structure that was being passed around, and defined it in one of these common folders. So whenever someone would change an interface contract, it would immediately lead to a syntax error in all of these other components. So you cannot even introduce a faulty state into the system, right? So there's a lot of concepts here, but what I want you to take away is sometimes less is more, and don't always follow hypes. This kind of approach helped us to simplify our architecture and our delivery processes. We didn't need all the flexibility, and we could get rid of a lot of headaches in the process. Then we're coming to one other topic which is common in the DevOps area. You build it, you run it. And this is where I'm really curious. Is anyone doing like 24 hours of support for their application, right? One. What we had to invest a lot of time in building know-how is monitoring our application and understanding how to monitor it, what kind of metrics and what kind of alerts we should define. And obviously, I would say here, perhaps the most important lesson learned is that tools can take you really far. And we're building on a really native Azure stack, which means that all the metrics from the application in the infrastructure flow into one central system, and you are able to see events and correlate them between each other. So what you end up here is, even though we have a distributed system, as you've seen, you get a distributed transaction analysis. Where do you see, okay, there was an HTTP request, which led to a database call, which led to a message to be sent, and so on and so forth, all tracked inside the same tool. And one cool way that we do it, I'm curious if you want to share some of your experience. We defined alerts and have them pop up in our messaging, in our Teams channel whenever some specific events occur or some thresholds are hit. And what the difficult thing is, you can't have too many alerts pop up in your chat, because at some point the team just stops responding to them. So this is like a continuous process of adjusting your alerts, seeing what's really important, and learning, and once again going into this continuous improvement process. By the way, has anyone used the Azure application map? Does this sound familiar? This is a really cool tool that helps you visualize your application in real time. So I see my components and how they communicate with each other. And I'm also able to see what kind of requests lead to failures. And the cool part is I didn't have to do anything for this. It just comes out of the box. Okay, one last point before we go into the more practical part and the discussion is, let's say, DevOps in the enterprise. I don't know, who of you considers yourself as working in a corporation or a bigger company, let's say above 100 employees? Okay, above 50? Or 50 to 100? No? Below 50? All right, so that's a good distribution there. So there's one point here. I mean, if we're talking about truly enterprises, right, where you used to have these, if you've worked with corporate customers, you know they have these IT organization, and then the switch to DevOps it really isn't trivial. And the question always comes up, well, okay, we want to do this fully automated fancy thing, but what about compliance and regulations and governance, right? So I'll give you a few examples. In the pre-cloud world, whenever someone needed like a virtual machine or whatever, they had to open a ticket to the IT guys requesting a virtual machine, and then you had this kind of well-defined process, but which is manual, and which also includes all the necessary verifications. It's a slow process, and it requires alignment between units, but it at least ensures compliance and governance. And then the customer typically says, okay, well, how do I do this in the new world, where you guys always want to do infrastructure as code and continuous deployment? So I'll answer it with some of the Azure tools that we've employed. So for example, let's say you as a company want to enforce that only specific services are being used, or maybe a service plan which is not the premium one that costs 10,000 euros per day, but a bit lower one, or only services in a specific region because your customer is requesting that. So that's the kind of things that you would ensure through Azure policies. At the same time, there are industries, and we're working a lot in the financial services industry, where the regulators always say, yeah, okay, you guys, you want to do continuous delivery, but if you want to do a change in production, I need a third party to approve that deployment, because that's just how the law is. And there are just some things, and if you are in one of those industries which you cannot circumvent, but I will come to that next. The good thing is that with a tool like Azure DevOps, you can model your workflows, and if necessary, and that's what we did, you can include also manual approval steps, let's say. So for example, what we require is approval on infrastructure level, and that's where we do have a manual approval step, but application changes we can handle as a team on our own. But you could do both. It's up to how you model the workflow. All right, so now I will open it up to a discussion, and in the meantime I'll jump into the Azure DevOps and just show you a little bit how one of these processes could be modeled. What you see is basically a flow where what I like about Azure DevOps is that it covers really your whole life cycle. So you can start with the planning phase of your agile backlog, and it enables the whole building, delivery, and running of your application. So it's integrated out of the box, obviously with Azure if you're targeting it as a runtime environment. All right, you have any questions? Would be good if I would have activated my internet. Just a second, sorry about that. Texylvania 32. So this is the result of our survey, by the way, which I have to say is better than expected. So kudos to the ones of you that do it every few days. The high performers, at least we haven't reached that level, but I guess you've seen that they allegedly deploy multiple times per day. So maybe you're in the high performer area indeed. All right, so I just want to recap some of the things that we've talked about. What we created here is a flow where we work based on pull requests, but we do try to make that process as smooth as possible. So we start off with a user story. I will just reopen this so I can use it. Did anyone use Azure DevOps? Did I ask that? Azure DevOps? 1, 2, 3, all right? Okay, so what I can do is I just define a new branch, and I can immediately tag one of the user stories, and I find this really cool for later traceability, because what we ended up with was the question, did we actually deliver this story to production or not? So in what environment was it? And this is a nice feature that actually enables you to keep track of that implicitly. So I've created a small branch. I can just create a new file, whatever. And I just want to show you some of the features that I like the most about Azure DevOps. So here we're going into the pull request flow, and for every branch you define different pull request validation flows. So in this case, you see it needs like a code review from at least one reviewer, but it will also run several validations. So one is, as I mentioned, it might be just checking your coding standards. Is it compliant and so on. But what we also integrated here is a release pipeline, which is triggered by this pull request, because what we've seen is, okay, I've developed a new feature, and I most commonly immediately need an environment in the cloud where I want to test this feature. So you have this possibility to define a deployment pipeline which is triggered by a pull request specifically. And then already here you could start implementing some of your flows where you, it depends, maybe you have a peer developer that would check it in your cloud environment, or it's the actual developer doing the work that checks it in here. And once this is done, I think I won't wait for everything to complete. Yeah, I won't do it. So once this is done, the pull request is being merged, and then the actual deployment can start. And this is where this whole idea of build once, deploy everywhere comes back. I only want exactly one artifact to be generated, and that same artifact is being then deployed across the different environments, right? So it could be QA, it could be prod. And here I can implement workflows. Like for example, over here, I might have my product owner that needs to apply the feature in the staging environment, and then on prod, if you're in one of those unfortunate industries where you, from compliance perspective, you need an external to approve it, you would send an email to that guy and say, hey, please, I have a new deployment, check it and release it. And what Azure DevOps does on the fly is that it keeps track of what kind of new features are coming in with every new release. So if, let's say, if I take one of these deliveries, here you can already see the user stories that have been attached to this deployment. So some release manager would say, okay, this is fine, this can go to production. And then this is where you would do it. I'm not going to make it any longer. I would rather just take some time to discuss questions if you have. Sure.
Hello. So earlier you were saying that you switched to a monorepo approach. Have you considered a multi-monorepo hybrid approach on that? So let's say some components are kind of isolated from the others, so you would deploy them separately. For example, in a website, maybe the landing page changes more often, and you just deploy that one and you leave the other deployment alone.
We haven't had the need. We're actually still in the process of bringing further components into that monorepo. So, okay. For example, we have things like scripts which help us with the delivery or migration and so on. We actually want to maintain everything in there because it's a lot easier also with development onboarding, developer onboarding. Here's your one repo, check it out, have fun. Mm-hmm, but mm-hmm. I do see that there might be situations where what you're describing makes sense.
Yeah, well, I just wanted to check if you tried it. And
no.
Okay, thank you.
Yeah, thanks for the presentation. Liked it. I have a question regarding to the project setup. Do you guys use something internally related to maybe Azure or any other third-party services, like just onboarding a new developer, something like having new developers on board very quickly, like making config of the local development environment?
So you mean from a purely technical point of view?
Yeah. Yeah.
So we have invested quite a bit in scripting some automation scripts which set up your local environment, and that mostly involves, for example, configuration, because the application, in order to run, needs some configuration which might be a secret, and we don't publish that in the source code repository. So we have some scripts which download the necessary information and set it up on your local computer. And for that, you just need, for example, an Azure account. So you first get your Azure account, you log in with your Azure CLI, and then you run some scripts. and it kind of sets up your environment for you. But it's not fully end-to-end automated in the sense that I run one script and I'm ready to go. We're not there yet.
I was referring to the more like developer side, meaning that a new developer comes in the team and just clone a repo and maybe have the perfect setup for maybe some preferred settings on the IDE, which is used for the development.
So there is still quite a lot of, we still need the good old-fashioned documentation in text form, meaning we write in there, okay, please use Node version X, use Visual Studio Code, and so on and so forth. But the source code repo also does come with some configuration for Visual Studio Code. So assuming you do install it on your computer, when you open the repo, it's already comes with our presets with regard to code formatting and so on and so forth.
Okay, thank you.
Any other questions?
Hello, thank you for the presentation. How do you decide what to automate? So what to test? What flows to test? Maybe even if you have side effects in the application, so one flow affects the state and that could affect another entirely different flow.
Yeah, so there are a few things here to consider. First of all, so we have this, I guess you know this idea of the testing pyramid, maybe, where at the base of the pyramid we try to write those unit tests, which you can write as many as you want. But what we want to make sure is that as you go up, those tests become more and more brittle. So if you have a lot of them, you spend a lot of effort maintaining them. So there we only have, basically we have one scenario which we test end to end. That's what we call the critical business case. And that's actually not even run in the build process, but we run it, it's called synthetic monitoring. So we have an environment, and every day at 8 a.m. A process starts in our testing environment that goes through that business case. And if something breaks, okay, we know we introduced some kind of error. And what this leads to, yes, this is a big nasty problem, test data management, right? This is a constant headache. And one that I don't have a really good answer for. We also try to make sure that tests always clean up their data, but it doesn't work. It maybe works 8 out of 10 times, let's say.
Thanks.
Hey, I have a question. So you said build once, deploy multiple times. Let's say you're developing two features in parallel, feature A and feature B. Feature A, feature B don't know anything about them. You build them both in parallel and then you basically deploy them. That means that the second one that gets deployed will override the changes of the first deployment, doesn't it?
Well, I mean, build once refers to the idea that assuming you have some code base, whatever code version it is, that you don't rebuild it for your dev stage and prod environment, because that alone can introduce, that the build process can introduce differences, but that is based on the assumption that it's the same code in the end that you're building. If you have two features, I would say you first have to merge them into your main development line and then build them and deploy them.
Yeah, but that's where the problem comes, because you want to build them before merging into the master.
No, we do build them after. So the idea is just you do build the master, but you try to. So if you take your example, you have two features. first one will be the lucky one that gets to merge to master. The second one needs to have the hassle of merging, handling any conflicts if there are conflicts. But if you do, if you work in small batches, you reduce the likelihood of having conflicts.
So basically what you're saying is before you can merge feature B into master, you need to do a rebase or...
So rebase would be one option, yeah, or a merge, yeah. Thanks.
Hey, do you have dedicated people for doing the on-call stuff? I mean, do you have SREs, or is the actual developers who are writing code are also in charge of doing on-call and writing code during being on-call?
So we actually, our team at least, doesn't do 24/7 on call. So how we are structured, we have a separate organization that kind of handles this first and second level contact to the customers, and they are available 24/7. We're just available during regular business hours. So we also, through that, we are offering software as a service, but we are not yet set up for 99.999 availability, for example. We're still working on, this has huge implications, as I'm sure you're aware, also on the organization, but we're not there yet.
Thank you.
All right, so thank you very much. This has been fun for me. I hope it has been also for you. So enjoy the rest of your day.